in this homework problem, we're given an aluminum cylinder with a length 10.0 centimeter and has a radius of 0.25 centimeter. Then we're given a mass of a single aluminum atom, which is an extremely small number, 4.48 times 10 to the negative 23rd gram. Very small. And it's tiny. Calculate the number of aluminum atoms present in a cylinder. And we are given the density of the aluminum as 2.70 gram per cubic centimeter. So the problem is we have a cylinder. Let's try to draw a cylinder here. Okay, then it is 10.0 centimeters and radius 0.25 centimeters. Now, use the geometry knowledge, we know that we can calculate the volume of this cylinder. And let's write it out. The volume of the cylinder, it is the length times the area of intersections. And the intersections right here is the circle, and the area of the circle is pi r squared. So therefore, the volume equal to length 10.0 centimeters times pi times r squared. And r is 0.25 centimeters. Now, how can we know how many aluminum atoms in this cylinder? So we are given the mass of a single aluminum atom. Okay, now what need to know of the cylinder? Then we can calculate how many such atoms present in this cylinder. It should be mass, because one aluminum atom is weight on this much gram. So if we know the mass of the total of the whole cylinder, we should know how many aluminum atoms are there, because there's nothing else in the aluminum cylinder. It's only aluminum atoms. So therefore, to calculate the number of aluminum atoms in this cylinder, and based on the mass of a single aluminum atoms, we just need to know the total mass of the aluminum cylinder. Then we can calculate the number of aluminum atoms equal to the mass of the cylinder. We'll divide that by the mass of a single aluminum atoms. So how to calculate the mass of a cylinder? We know the volume, and to calculate the mass, we need, the density of aluminum. So therefore, the mass of the cylinder equal to the density of the aluminum times the volume. And if we plug this back into this equation, so the number of aluminum atoms equal to the density times the volume, divide that by mass of a single aluminum atoms, and density, we know that. Okay, first then we need to plug the volume in here. So let's finish this. Density times the volume is actually multiply of length times pi times r squared, divided that by the mass of a single aluminum atoms. Now we have complete our equation. We want to know the number of aluminum atoms. We have the density here known, the length here 10.0 centimeters, pi is constant, r radius 0.25 centimeter, and the mass of a single aluminum atoms, which is in here. Now let's plug in all the numbers and along with the unit. Density 2.70 gram per cubic centimeter times length 10.0 centimeter times pi times 0.25 centimeter This is radii the square. Divide all of this by a mass of a single aluminum atoms. Now pay attention to the sig figures. We have 3 sig figures here, 3 sig figures here. Pi is a constant. We can take as many as we want, and we have only 2 sig figures from radii and 3 figures here. So as the final answer, we can only keep 2 sig figures. So after total calculation, we finally got 1.2 times 10 to the 23rd aluminum atoms. And that's the end of the problem.